What's up, young mathematicians? Thank you for stopping by here at Talk to Pi. I am Caesar the Tutor, and today we're going to talk about the graphs of the basic functions. In Algebra and Algebra 2, you're going to see some of the functions over and over again. So it makes sense to learn what the basic shapes are so that whenever we're asked to modify a function, we know exactly what it does to its graph. So let's get started.
Let's begin with the simplest of the big six, or 7, or 8, as you will see. F of x equals x. This is the parent function of the linear function. So this is going to graph a line. Let's take a look at the graph. And we know it's a slope of 1 with a y-intercept of 0. So we're simply going to draw a diagonal line. And from the function, we can see that whatever x equals f of x equals, or whatever x equals y equals, perfectly diagonal. The domain is going to be negative infinity all the way to positive infinity. And the range is also going to be from negative infinity all the way to positive infinity. The next graph that we're going to look at is going to be the quadratic function. And the parent function for that is the f of x equals x squared. The x squared function has a shape, basic shape, of a parabola. And from the graph, we can see that the domain of this function goes from negative infinity all the way to positive infinity. And the range of the function in this case starts at 0 and goes all the way to positive infinity. And this actually should be a bracket because we do start at 0. The third function that we're going to look at is going to be the cubic function. And that is a function f of x equals x cubed. That will be the parent function of the cubic function. And the graph of this one looks like this. From the graph, we can tell that the domain is negative infinity to positive infinity. The range is also negative infinity to positive infinity. Up until now, we've seen graphs and functions whose domains are from negative infinity to infinity. They cover all x's with no restrictions. We did see one graph that has a restricted range, but now we're about to see a different graph that kind of makes the domain a little weird, but it should already make sense why. And this is going to be the square root function. And we have f of x equals root x. Now notice that just by looking at this parent function, we know x cannot be negative. If x is negative, we're going to get some nonsense, or, well, actually it's going to be a complex or imaginary number, but in the reals it doesn't exist. And so therefore we cannot use x. It's negative, so x has to be greater than or equal to 0. And the graph of this function looks like this. Starts at 0. We get 0, 0 is a value. And then we go that way. Okay? The domain of this function starts at 0 and goes all the way to positive infinity. So it starts at 0 and goes all the way to infinity. The range starts at 0 and goes all the way to positive infinity. Another function that has a restriction on its domain is going to be the reciprocal function, which is the parent function of the rational functions. So it's going to be f of x equals 1 over x. Now, by looking at this, x cannot be 0. We already know that x cannot be 0. And the graph of this function looks like this. Now, this function has a very particular feature. Two, actually. One is called the horizontal asymptote, and the other one's a vertical asymptote. The vertical asymptote occurs at the value of x equals 0. X can never be 0. At no y value can x ever be 0. And so we put what's called an asymptote. And f of x can never be 0. Y could never be 0. There is never a value of x that will ever give us a value of 0. So then y, or it'll never touch the x-axis either. We go ahead and label these x and f of x. And the graph has a very particular shape. It's called a hyperbola, and it's in a very particular position. So it never touches the x-axis, and then it bends down, and it's never going to touch the y-axis either. Now, on the other side, it's going to start here, and it's never going to touch, and it's going to bend a little, and then it's never going to touch the x-axis on this side either. So this is definitely the most different graph of all the others. And so to look at the domain for this function, we want to see that it begins at negative infinity, and as it approaches this asymptote, it bends down, and it never quite touches 0. So it's going to start at negative infinity, and it's going to go all the way to 0, not including that, not including that. On the right-hand side of the equation, or the graph, we have start at 0 and continue all the way to infinity, but we don't include 0. So then on the other side, we're going to go from 0 to infinity. And since we need both sides of the graph, I'm going to put a union symbol here, and that's my domain. The range, similarly, starting at negative infinity, going all the way, but not touching 0, skipping 0, and then going from 0 all the way to positive infinity, as you can see on this side. So we say range is negative infinity to 0, union 0 to infinity. So that's going to be the range of this function. The next function that we're going to go over is going to be the absolute value function. So we have f of x equals absolute value of x. The absolute value of x is a graph that on the right-hand side of the y-axis, it forms this line, and on the left-hand side, it forms this line. And so we have our basic absolute value function, which looks like a v. It is the first function that we see that actually has a corner. And since everything that comes out of the absolute value function is positive, we know that the entire graph is drawn on the positive side. Now, of course, once we add transformations, we're going to be able to move this up and down, left and right, and do all sorts of things. But for now, the parent function, this is what it looks like. Let's look at the domain. The domain of the function, well, it starts at negative infinity, and it goes all the way to positive infinity. And that makes sense. I can put anything in here, as long as it's a number, or a real number, and I'm going to get a valid output on the plane. So we get a negative infinity, not going to include infinity, all the way to infinity. Now, the range, well, that one's going to start here and go all the way to positive infinity, so the range is going to be from 0 to infinity. Now, as you saw, that was 6 functions, and we're actually going to add another one because some teachers like to include it in as part of the 6. So then it becomes 7. And so we're just going to call it like this. We're going to say y equals the square root of 1 minus x squared. Now, what is this? This is a semicircle. It's a semicircle, therefore it's a function, which means that I should have written it as f of x, but that's fine. F of x equals that. Now, something particular to note, okay? This number here, that's the radius, okay? It's actually supposed to be, the general form would be f of x equals the square root of r squared minus x squared. So then r, that's the square root of that will be the radius. So in this case, the radius is 1, so we can put a 1 here, a 1 here, and a 1 here, but of course this one's -1 because of the negative axis. And our semicircle simply goes like that. Domain of that is -1 to 1. Ah, that's the first one we get where it's not going to infinities or something like that. So we have domain, which is going to be -1 to 1, including -1 and 1. And then the range, also another one that doesn't go to infinity, is going to be from 0 to 1, including both 0 and 1. Now you might be asking yourself, okay, why is this here? How do we come up with this? Well, the general form of the circle is x squared plus y squared equals 1. But if you graph a circle, you will end up with a whole circle, of course, which then does not satisfy the vertical line test. When you take the vertical line test of a circle, you get 2 points. And we know that that's not possible because the vertical line test is supposed to only touch 1 point in a function. So then what we do instead is we solve this function for y, and we want to see what's going on here. So let's subtract x squared from both sides. And we get y squared equals 1 minus x squared. From here, if we take the square root of that, and if we take the square root of that, now the square root of y squared is going to give us plus or minus, or actually, it's going to give us the absolute value of y equals, well, just the square root of 1 minus x squared. Now, because this is the square root of y, or sorry, the absolute value of y, we know that it's supposed to be a plus or minus somewhere, so we get rid of these absolute values and we put a plus or a minus here. And that's where we get both halves. The positive half of that function, or that expression, is this side. The negative half is this one. And we want to get rid of one in order to make it a function. So I'm just going to get rid of the negative one. I'm going to say, okay, I don't want that. I don't want the negative one. I just want the positive. So I'm going to make it f of x. Now it's a function. And when I graph it, I'm going to get rid of this part. And when I take my vertical line test, as magic, we end up with a function. So that's how we end up with that. And some, like I said, some courses, some teachers like to include it as one of the ones you should know. So that's why we're including it here. Now let's take a look at all these functions side by side. If we take a look at f of x, g of x, and h of x, which are the top 3 functions here, we notice something similar. X, x squared, x cubed. The top 3 functions are all polynomials. In general, polynomials are going to have the domain from negative infinity to positive infinity. Just all polynomials have domain negative infinity to positive infinity. Now, let's take a look at this one over here. A of x has a corner, k of x has asymptotes, and r of x has that little weird beginning because it's the absolute value function. But here you have all your basic functions.
And that will be all for today. Thank you for stopping by. If you liked the video, make sure to hit the like button. If you want to see more content like this, make sure to hit the subscribe button. I will be uploading every day on different topics. If you have any ideas, if you have any questions, if you want me to cover a specific topic, go ahead and mention it in the comments below. And as always, if you have any questions, comments, concerns, or emotional outbursts, drop them below. Thank you for stopping by.